Hi everyone, I hope you are doing good. So today in this video we will take a new DSA questions, and here basically there are multiple questions related to this. So we will discuss left view of binary tree, right view of binary tree, and then we will discuss top view of binary tree and the bottom view of the binary tree. So I will explain what are these things, right? These terminologies, and once you understand these terminologies, left view, bottom view, right view, top view, then we will discuss how can we implement the algorithms, right? And then I will add the C++ code where we will print the left view, bottom view, right view, and top view. Correct. So we will go one by one, right? So basically there will be 4 videos, and each one is covering the one view basically. Correct. So let's start with this left view binary tree. So here let's understand first what is left view. So the question is given, you are given the root of binary tree. Your task is to return the left view of binary tree, and the left view of binary tree is the set of nodes visible when the tree is viewed from the left side. If the tree is empty, then return the empty list. So this is the question. So let's understand what is left view. So let's take this example here. Right. So it is saying when you see the tree from the left side, right, then all the viewed node, all the nodes which you can view, those comes under the left view. So or in simple words, what you can do, just draw a line from left to right, because you are standing here, you are standing left side, right? You are standing left side. So what you can do, you can see from left to right, correct? So just draw one line, a like this horizontal line from left to right, correct? This one, right, on each and every level, correct? Now see, whatever the nodes which encountered first, those will only be visible from the left side. Why? For example here, right, 2 and 3. So 2 is encountered first and then 3, right? So 2 is hiding 3, this node, right? Or you can say 2 is in front of 3, or in other words you can say 3 is behind 2, so you cannot see the behind one, right? You can see only front one only, correct? And same applies for 4 and 5, right? So here this side is the left view of this tree, correct? I hope you are getting it. So now what will be the output for here? So if you see from the top, so here first one, like this one, this encountered first, so this would be the or left view. You can see one node, then 2, you can see, yes, it got encountered first, right? So 2 will be your output, and this 4, right, because 5 is behind 4, so 5 you cannot see from left, but 4 you can see, right? So 4, so 1 2 4, this would be your output, right? I hope you are getting it. uh, and same applies, same method applies for right view, same applies for top view, same applies for bottom view, right? For right view, what we can do, we can change the direction, right? We can instead left this okay. So for right view, what we can do, we can change the direction, right? And we are standing right side, right? And then we are looking from right to left, right to left, right? And what are the nodes we can see? First is 1 3 and 5. 2 we cannot see from right side because 3 is in front of 2, right? And 5 is in front of 4. So 4 and 2 got hidden basically by their front nodes, correct? So 1 3 and 5 would be the output for right view basically, correct? So in this video we will discuss the left view first. So and then I'll explain the bottom view and top view as well in the upcoming video. So let me take another example here. So this one, right? So here what would be the left view result here? So when you look from left to right, so you can see first would be your output, because we can see first, we can see this 2 node, right, this one, but we cannot see 3 because 2 is in front of 3, correct? We have draw the line and 2 is encountering first and then 3, so 3 got hidden by 2, right? So 2 would be your output, and then 4, right? Nothing is in front of 4, so 4 we can say, and 5 we can say because nothing is there in front of 5, so 5, so 1 2 4 5, right? 1 2 4 5, this would be your answer. I hope you are getting it. It is very simple. You can easily understand it. What we will do, we will just draw the line, horizontal line, and we see whichever node encountered first, that would be our output basically, right? Or those are the nodes which we can see from the left. Now think about solution. How can we do this one? How can we achieve this solution, right? What would be the efficient algorithm to solve this problem? Uh, yeah, if you have any different solution algorithms, then whatever I will discuss, then please comment below the video and let us also know, right? Else I am showing whatever I'm thinking. So what I will do, I have multiple solutions for this one, because tree traversal, we can do the in-order tree traversal, pre-order, post-order, level order. We can make anyone use of anyone. So here what I will do, I will show you using the level order as well, because see here why level order I am taking, because we are going level by level, right? What we are doing, we are doing line, right? So these are the levels only, right? So you can say first level, second level, third level, correct? So and on each and every level, when we go from left to right, we are printing the first one only, right? First one, whatever the, so on this level, first level we are printing the first node, correct? Second level we are printing the first node, and third level we are printing the first node, correct? So we can make use of this level order tree traversal techniques, right? So let me show you my implementation for this algorithm. So this is the one approach I have implemented here. So here what I am doing, see here what I am doing, I am going on each and every node. If node is null, then we are returning itself, right? Else what we will do, we are just if the resultant array, right? Whatever we are taking the resultant array vector, right? And initially the vector would be empty, right? So the size would be 0, right? So res size, right? It would be 0 initially, correct? And we are at root, correct? And the level of this is 0, right? Or you can say 1. Level of this one is 1. This is 1, correct? So now see, the size of resultant array is less than the level. It means we did not put the this number or this node value into the resultant array. So what we will do, we will add this one to resultant array. So right, so let's just add it 1. So 1 got added now, right? Now the size and level is same, right? Size is 1, it becomes 1, and level is 1, right? And then what we will do, we will check for the next level, right? So here what we are doing, we are just incrementing the level plus plus. Either you can do here, or level plus 1 you can add here and here also, right? Line number 66 and 67. I hope you are getting it. So what we are doing, basically this is the recursive approach, right? After this I will show you the level order approach as well, correct? So here we are taking the input basically as a IO parameter, input output parameter, and in that we have the vector of the integers. So this would be your result. That is what expected from this solution, right? And this array, this resultant array, should have the left view, basically left view nodes values, right? Whatever the nodes we can see from left, so those nodes keys should be there in the vector, right? So now initially the vector would be empty. See here, the vector is, we are declaring here and we are passing it, so it would be empty, correct? And if it is empty, then size would be 0 and level is 1, right? Because we are starting from the first level, right? So and if the resultant array size is less than the level, right, it means from this level we did not add any number to the resultant array, correct? I hope you are getting it. So now this condition is true, so we are adding this node arrow data. So 1 we have added to the vector. Now size becomes 1, right? And now we will first this level got added, so now we will check for the next level, right? So this is 2, this is 2, this is 3. So now 2, right? So node arrow left, level is 2, and then resultant array we will pass as a reference, right? So we will go to this node. Now what we will do, we will go to this node, correct? And here we will check res.size, that is 1, and level is 2, correct? This node is at 2 level, so we will add this value 2 to the vector. So we have added this one, and now we will go for this here, increment the level, and then we will see node arrow left, then we will go to this node, correct? 4, and here also the size is 2, see, because we have only 2 numbers, the size becomes 2, and level is 3, right? So we will add one more number here, this node value, that is 4, correct? And then we will go to the left, increase the level, right? And we will go to the left, but left is null, right? Because this node arrow left is null, so we will come back and we will go right. Right is also null, right? Then we will come back, and from here we will come back here, right? After this one, after this function we will return and we will come back to here, this one. Now here you see we have the right, this node arrow right we have, right? So we will go there from this one. So and then the level is 3 here, but the size is 3 already because we have added 3 this 4 from this level, right? So what we will do, we will not add anything to the resultant array here. We will skip that basically, because from this level we have already added the number, and that we can see from the left side, right? So we will come back now. After this we will go, we come back here, we will not add this one to array, then we will go left, we will come back, then we go right, then we will come back, and from here we will come back here, and from here we will come back here, correct? First, right? And this got already added, so now from here we will go to the right side, and from this level also, because at this point the level would be 2, right? At this point the level would be 2. So and the size of the array is 3. It means from this level also the front number got added already, so no need to add it. So that's why we will skip this one here, right? Because the res dot size would be 3 and level is 2, right? So this condition is false. And then we will increase the level from here, then we will go back to the left of this node, that would be null, we will come back, then we will go to the right, we will come back because that is null, and from here itself we will come to the root, and then we will return, right? And now we are basically out of this function, but we have added these 3 numbers to the or resultant vector, right? 1, 2 and 4, right? And that is your answer. So I hope you got this approach, right? It is very basic approach. If you know the tree traversal techniques, then it would be very easy for you guys, correct? So let me explain the other approach as well with another example. So here the another approach is the level order traversal, right? So in level order traversal also the thought is same behind the level order as well. So where what we are doing basically, so these are the levels, correct? And in level order traversal, you know, we use queue, correct? So first we will create one queue and we will push one node, right, root node to the queue, and then we will run the while loop till the queue is empty, correct? And here what we will do, we are basically taking that node out, the front node from the queue, and that would be your root, right? So we are taking this out and we are pushing this into the resultant array, right? So this is your resultant array, so we will push it into the resultant array, that is 1, right? And then and here also we are calculating the size of the queue. The size of the queue is 1. So what we will do, because in the queue, so for example this is your queue, right? So now in queue we have 1, correct? So now what we will do, and the size is 1, it means one node from this level we have to pop from the queue, we have to remove from the queue, right? Size is 1 and it is greater than 0, so we will go inside this while loop, inner while loop basically, right? And we will take this node to the front of the queue is into the node, and we will pop it out from the queue, right? And we will reduce the size. Why reducing size? Because we have popped out the one element from the queue, that is why we are reducing the size by 1, right, from here, right? And then for this node, whatever the popped out node, if it is having left, then we will push it to the left of the that node into the queue. And if it is having right node, then also that right node should be pushed into the queue as well, correct? So yes, so one is having left 2, so we will push 2, and it is having right also, that is 3, and this one is got popped out already, correct? So one is okay. Let me remove this one now. So now, and then we are because queue size becomes 0, so we'll come out from this loop, while loop, right? And here queue is not empty because it is having 2 elements, correct? I hope you are getting it. If you have any doubt query, then you can comment below the video. I will cover your doubts queries in upcoming videos as well, so that is also fine, right? So now here queue dot size would be 2, right? It becomes 2, and then we will take the front of the queue, that would be 2, right? And see, the logic is same. We are taking the front because when we are basically pushing the left first and then right, so on each and every level, right, the front node would be seen from the left side, right? Only the front node would be seen, correct? So that is why we are taking front node here, right? In our earlier approach also the logic was same, correct? So here we are taking 2 out, and we are putting it into the resultant array, and then we are going behind the inner loop where uh, like all the nodes we have to remove from the queue which are from the current level basically, right? So on this level we have pushed 2 and 3, right? So 2 and 3, so we have to remove these 2 and 3, and we have to put the lower level nodes into the queue basically, correct? So here we will come and we will take the 2 node out, this one we will take out, right? And we will here we will pop this out, then we will reduce the size, so size would become 1 here now, correct? And then node arrow left, so 2 arrow left, that is 4, so we will put 4 inside this one. And then the right also is not null, so we will put right, correct, from here. And then we will go up, and here size is 1 now, so one node one more node we have to remove from the queue. So this 3 is also out, here size would become 0, right? And we have popped it out because then it becomes empty, not empty, the size would become 0, correct? Not empty because we have added the 4 and 5 as well, so the queue will not be empty here, correct? And then this 3 is not having left or right, 3 arrow left, that is null, 3 arrow right, that is null, so we will not push anything here. And then we will come out from this, and then we will go to the top of the outer while loop here, and then check queue is empty. Queue is not empty because we have added 4 and 5 here, right? So let me remove this 2 and 3. So now here 4 and 5 is there, so the size of the queue would be 2, right? It becomes 2 again, right? And then we will take the front from this queue, that is 4, right? So we have taken 4, 2 and 1, right? So we will take 4, so right, from this level, correct? So this level, so basically after coming out of this inner while loop, we will have only that level nodes, right? That particular level nodes. So for example, this time, so we are coming out, we are out of this inner loop, so now we have the all the nodes there are there in the queue which are from the this level, right? See 1, 2 and 3, so third level only, right? So now we have taken this 4 into the resultant array, and then the size is 2, right? And then we will go inside this inner loop, and we will pop the 2 nodes from the queue basically, correct? Here we will take the front 4 into the node, and we will pop it out and we will reduce the size, so it becomes size becomes 1, and then node arrow left, that is nothing there. 4 arrow left is null, 4 arrow right is null, so we will not do anything. Then we will take out 5, right, because size is 1, so now size becomes 0, correct. And then this 5 arrow left is null, right, 5 arrow right is null, so we will not do anything, right. And we will come out from this inner loop, and then we will go to the top of the outer while loop. So here q dot empty, it is true, right, and we are the negation of this value, so it becomes false, so the condition is false, so we will come out from the outer while loop, right. And then we will return the res, resultant array, and in resultant array we have 1 2 4, correct, and that is our answer, right. And I hope you are getting it, you understood the problem, you understood the solutions, how can we approach. Here we have tried recursive as well as the level order. Whichever you like, please tell me, let me know by commenting below the video. So yeah, that's all for today. In next video we will take the right view, and then upcoming videos we will take the top view and bottom view. Yeah, thank you.